Chapter 2, Exercise 2.105. Part A. Find the velocity of an electron emitted by a metal whose threshold frequency is 2.46 times 10 to the power 14 per second when it is exposed to the visible light of wavelength 4.76 times 10 to the power negative 7 meters. So let's set up the equation. On the left-hand side of the equation, we will have the kinetic energy of the electron, which is 1/2 times the mass of the electron, 9.11 times 10 to the power negative 31 kilogram times v squared. So it's just 1/2 mv squared is equal to the Planck constant, the actual frequency minus the threshold frequency. This is how we set up the equation. H is the Planck constant. We can look up its value. And then we have frequency from this lambda, threshold frequency from this piece of information. The frequency of this photon is the speed of light divided by the wavelength. This is the speed of light in the SI unit divided by lambda. Alright, and we can click the equal sign to get the value of V. So over here, 747,635. Over here, we can round it up to 7.48 times 10 to the power 5. So this is how to tackle the problem using Wolfram Alpha. What if you have only a calculator? Well, I would do it step by step. So first, I would compute the frequency of the incident photon, which is the speed of light divided by the wavelength of the photon. We get the frequency of the photon. And then minus the threshold frequency. The difference multiplied by the Planck constant, that would be the kinetic energy of the electron. And then over here, if you look at this, we have the energy of the electron, and then times 2 divided by the mass of the electron, we get V squared. And then finally, we take the square root of V squared, we will be able to get the final answer. This is the setup of the equation in Wolfram Alpha. The actual frequency, the threshold frequency, the Planck constant, and over here we have the kinetic energy of the electron. And that's the final answer. And then we round it up over here to get this speed.